Welcome back. We're back to our old favorite experiment, the two-slit experiment. I would like in this clip to discuss a bit more what is this procedure of measurement, which we saw is central to understanding the results of quantum mechanics. Okay, so we're dealing with quantum mechanics. We have our favorite two-slit experiment. As we discussed in the previous clip, we have the initial wave function, which I still owe you how do we determine it, but that's for a future clip. And we have our measurement procedure. We observed the electron hitting a point at time t, a point on the screen. Okay, how do I deal with this development in time using quantum mechanics? Basically, in order to determine the propagation in time, I write down the Schrödinger equation. And from the Schrödinger equation, with the initial condition of the wave function at time t0, I can give you the wave function at any other time. So, although some of you may have heard that quantum mechanics is a probabilistic theory, at this stage, quantum mechanics is completely deterministic. If I'm looking on the development of the wave function as function of time, it's a result of a differential equation with initial conditions, and I can give you psi for any given time, and that's deterministic. Where does probability come into effect? Well, at the measurement. Basically, if I have the wave function, I can write down the probability of finding the electron at any point x in the system at time t. It will be just the wave function squared. But this is a probability. In this sense, quantum mechanics is a theory of probabilities. You want to know where the electron will hit the screen? Can't tell you. I can give you a probability of finding it at any point. What determines this position? Nothing that we know. But once we perform the measurement, we know exactly where this electron hit, meaning that in the process of measurement, we take the probability that we can extract out of the wave function, and perform a measurement. And in a moment, I'll say something more about what's a measurement. And after the measurement, I know that the electron actually hit the screen at a definite point. Perhaps instead of 0, I'll describe it as 1. It hit at x1. So, before the measurement, we had a probability that came out of the wave function. This probability develops with time. We know exactly how it develops just by looking at the Schrödinger equation, calculating the wave function, squaring it. But after the measurement, we have no probabilities. We know exactly that we measured the electron at a given point. This is known as, in the Copenhagen interpretation, as the wave function collapse. Let's stop a minute and think about it. This is a very strange occurrence. Basically, we started with a wave function which develops with time in a smooth, determined way. Then we come and say, we perform a measurement, and then suddenly we go from some form of the probability function to a very different one, and that occurs at the moment of measurement, and that procedure, this occurrence, is not described by the Schrödinger equation. This is something that happens out of the theory. Now, this is a very nonlinear procedure, very different from what the Schrödinger equation. And at this point, we have to stop and say, what happened here? And as we will see in following clips, this is actually one of the most problematic points of quantum mechanics, a point that is not well understood until today. Nowadays, there are two main explanations of this procedure, of this occurrence. One is the Copenhagen interpretation, which basically says we indeed have a wave function collapse. It's caused by measurement, and then we are faced with the problem of what is a measurement? Who can perform a measurement? An experimentalist, a dog, a conscious being, a mouse, as Einstein, who very much disliked this interpretation, said, I refuse to accept that a mouse staring at the universe changes its development. Or the other explanation that's nowadays gaining in popularity, although it also has its own problems, is the many-world interpretation, which you might be aware of. It became very popular in the general public. Nowadays, half of the movies you go to see have this interpretation somewhere. But also, this interpretation is not without its own problems. And we will discuss them some more in the next clip.